talk right triangles. What do I mean by a right triangle?
90.
Yeah. We know it's got to be a triangle with a 90-degree angle.
Not the hypotenuse.
And, okay, notice, am I putting this on a coordinate system today?
No.
Okay, for this part, no, we're not on a coordinate system. So, are we going to label our angles with alphabetic letters or Greek letters?
Greek. I hope Greek.
Alphabetic.
Greek was when you're on a coordinate system. Normal alphabet is when we're out here on the plane. Okay, when I label a right triangle and I call it ABC, which angle is automatically supposed to be the right angle? Side C is the hypotenuse, therefore angle C would be where? The one opposite. So angle C is always the right angle. Okay, I didn't write that very large. The sides are lowercase, the angles are uppercase letters. Doesn't matter which angle you call A or B, the two acute angles, but the right angle has to be C. Okay, so where's side A? Between B and C is opposite angle A. And so side B is opposite angle B. Yeah, this should ring a bell. So then, if I wanted to actually set one up with numbers here, if I told you, say, that this was an 8, 15, 17, it didn't correct itself. There it goes. Okay. This is an 8, 15, 17 right triangle. Which one has to be C? So hypotenuse has got to be up here, or right angle's got to be up there. If I said to you, find me the sine of angle A, do you guys remember how you did that?
Adjacent over hypotenuse.
Yeah, you had a saying for remembering.
We didn't have a
Yes, you did. Yes, this is Oscar had a heap of apples. Okay, but what were the three trig functions that went with it? Yes, sine, cosine, and tangent. Okay, for these kind of problems, there is no need to have secant, cosecant, cotangent. You can solve everything here with sine, cosine, and tangent, so you won't ever see the other three. That's why you didn't learn them in geometry. Okay, so what does the O, the H, the A mean?
hypotenuse. Opposite.
Yeah. Opposite, hypotenuse, adjacent, hypotenuse, and of course opposite over adjacent. Now, could you do the other three trig functions with these? You could. Cosecant is hypotenuse over opposite. You could turn these upside down again, but there's really no need to. You can solve everything you need here.
So there isn't one opposite over opposite?
No. Now, this only works on the acute angles. You cannot do this on the right angle. This is only using angles A and B. You cannot use these with angle C, where you can't apply it to the right triangle, to the right angle. Only with the acute. Okay, so now looking at that picture, if I want the sine of angle A, how do you figure that out?
Opposite over adjacent. Opposite over hypotenuse.
So if I'm doing opposite over hypotenuse, what is opposite angle A?
15.
Opposite angle A is 15. What is the hypotenuse?
17.
17. And ta-da, you found sine is opposite 60, 17. Okay, would it be a different answer if I had asked you for the sine of angle B?
That's all we're going to learn. Yeah.
That would be still opposite over hypotenuse.
8, 17.
And so opposite of angle B is 8/17. Okay, that's exactly why you have to always have an angle with a trig function. You can't write sine. You have to write sine of some angle, because how do you know what to be opposite of if you don't have an angle there?
What about sine over C? Is 17 or 13?
You can't do, these only apply to the acute angles. It does not, you can't do it to the right angle.
Oh, okay.
You just, it's not confined to work that way. Okay, now, I want you to find some missing parts of triangles using these. You did this in geometry. Sometimes he does little projects on it. I don't know if you did that here or not. But these were the kind of problems, do you remember some problems that had like angles of elevation and angles of depression?
Yeah, that was a sad one.
That was sad?
Yeah, that was his joke. That was very sad.
Okay, so if I want an angle of elevation, If I am on the ground and I tell you you have an angle of elevation of 17 degrees, where's that angle? Up. Elevation means to rise. So from the horizontal line, your angle must go upward. Angles of elevation have to go from a horizontal line, they have to go up. Okay. We always get angles of elevation right. I never have trouble with angles of elevation. I get angles of depression messed up all the time. They cause us issues because angles of depression are measured from the horizontal line, that was supposed to be a horizontal line, from the horizontal line downward. So you have to start at the horizontal and go down to have an angle of depression. So we're going to see if we can solve some missing parts here. So now you get to see my very fine artwork. Okay, we have this tower here. Okay, and out here we have this very fine vehicle.
That is a foot of water. We're gonna find the shadow. No. That's an El Camino.
I'm not sure what it is. It was supposed to be a truck.
That is a truck. El Camino.
Okay, so if you're up here at the top of the tower and you look down at the truck,
That's an angle of.
and I tell you the tower is 90 feet tall, actually make that 94 feet tall.
45.
My question is, how far away is the truck if you know the angle of depression? The angle of depression is 25 degrees. Actually, we need to talk about this. We're going to make that 25 degrees, 40 minutes. We need to learn how to do that. We don't like that. Have you ever seen that? You want me to do 25 degrees, 40 minutes?
Yeah.
Okay, well, we need to learn this. I know when you look at a protractor, a degree looks like it's a really tiny small angle. How could you want something smaller? But sometimes we need angles that are smaller than 1 degree. We need to be able to measure in a fraction of a degree. And the primary reason is 1 degree on your paper is very tiny. But if you take a 1 degree angle and you extend it outward for miles, eventually that angle gets there because there's quite a bit of space in between there. So we need to be able to have smaller increments. People who survey and mark off property boundaries, when they're laying out where they're going to raise a highway. Okay. So since they need to know angles are smaller, they broke them down. But it's kind of interesting. If you break an angle of 1 degree down, there are 60 minutes. Just like time, there are 60 minutes in a degree. And you can actually go smaller than that. You can actually take a 1 minute angle. We represent minutes with a little prime symbol like we represent feet. You can actually break it down into 60 seconds. So I don't know who decided to call them that, but so you can break angles into much, much smaller increments if you want to. Yeah, 25 degrees you could do. Devin's saying since I have 40 minutes there, I could do 40 over 60, or in other words, it's 2/3 of a degree. Okay, your calculators are set up though, they'll let you put it in minutes. You can type it in, put the symbol on it, it works fine. However, before we do that, I need to have y'all check your calculators. If you go to your actually I got it written here. Go to your scratch pad and hit your little arrow up at the top of the scratch pad. Well, actually, I don't know who I'm recording for now. But I can keep recording, but our question is, how far is the truck from the tower?
3 degrees.
If I say how far, do I want an answer in degrees? I want a length, yeah, I want a distance. So I'm going to call this distance here x. Okay. What you have to do is you have to use your old friend Oscar, and figure out which trig function would this be. And we also talk, where is the 25 degrees, 40 minutes in this picture? Is it 25/40 right up here? Is that the angle of depression?
Yes.
Based on this definition, angle of depressions must be from a horizontal line down. Where would you have to have a horizontal line at? Okay, nah, if it's angle of depression and you're going to look down, yeah, you have to think, I have a horizontal line up here, because that's where I'm at sitting looking down, so this angle is your angle of depression. That's why I have angles of depression messed up so much. Now, here's the beauty of it. A little geometry pays off. You remember parallel lines cut by a transversal?
It's down at the bottom corner.
You have parallel lines here. You got the ground and you got our horizontal line at the top. You have a transversal, the diagonal line. So what other angle is equal to 25 degrees, 40 minutes? Yeah. An angle of depression is the same as the angle of elevation down at the bottom. Everything else. So I actually know then this one down here is 25 degrees, 40 minutes also. And now I have an angle inside my triangle that's easy to work with. So from that, since that's the angle we know, that's the one we have to set up an equation with. What sides am I working with here? Opposite, adjacent, hypotenuse? From this angle, I know opposite. I'm looking for adjacent. So I have to have the trig function that has opposite and adjacent in it. Which, if I pop back, opposite and adjacent was tangent. So we are going to go, oh, I need to do tangent. Okay, I have to have tangent of an angle. What's my angle? 25 degrees, 40 minutes. Okay, and we said it's opposite over adjacent. So which was opposite? 94 over x. Okay, you now need to get x solved for and then punch the rest of whatever's left in your calculator. There's actually a little slick trick here, but I'm going to do the algebra the normal way, then you can see the shortcut. I can't solve for x when it's on the bottom of the fraction. So what do I do? Multiply by what? Yeah. I multiply x over the other side, because I can't have that. Now, I want to get x by itself. So how do I get rid of this tangent so x is over here by itself? Divide the tangent over, so you'll end up with 94 divided by tangent of 25 degrees, 40 minutes. You'll notice what actually happened is the x and the tangent just switched places. They just flip-flop positions. So if your x is on the bottom, you can just interchange them. That's what's going to happen every time. Then you're going to go to your calculator, and you are going to punch this in to get your final answer.
What's the minute sign?
Okay. This morning also was different people had it different places on their calculators. I'm not sure why. Put a fraction in first. Do your 94. Okay. You have a trig button, which is right below your control button. And if you go in there and get tangent. Okay. Then, this is the weird part. I've already stuck it. You have over here on your, right next to your G, you have a question mark, exclamation point.
Where?
Right next to G, the letter G, there's a key with an arrow on it. Hit that key. You have a degree symbol and a minute symbol in there. Some people this morning also had it under their pi button, but not everybody had it under their pi button, and I don't know why. So
There's degree signs under both of them.
yeah, okay, degrees under both and
The minute.
minutes.
195.
Well, see, my calculator was that way, but other people didn't have minutes under pi. I don't know why there's a difference. So I'm a bit mystified on that one, but it's under the question mark, exclamation point. And so, yes, it's 1 6. Okay, 608. Okay, now trig books actually get in the real world. Oh, what time? Thank you. Okay, trig books actually get in the real world. In the real world, we have to worry about what to round off to, and this will use significant digits. So So you have to go back to your original problem and look at the numbers they gave you and go, how many significant digits did I have? 94 has how many significant digits? 2. It doesn't have any zeros, so they both count. That's 2. 25 degrees, 40 minutes has 1, 2, I know, it's okay. It's got 1, 2, 3. You take the smaller amount. The smaller amount was 2, so you have to round that off to 2. 2 digits, which means it's the first 2. So it's actually going to round clear up to 200. They would round that clear to 200 feet is what we were in.
And the nearest whole number?
However many digits it takes.